Hello everyone, welcome to my channel. In this lecture, we will discuss about the separation of benzene from air using Aspen HYSYS. So first of all, open the Aspen HYSYS. This is the click on new template. So Aspen HYSYS will open. So in this lecture, we will discuss how we can separate benzene from air from air. So this is the component list. Click on add and here add the component. First component is air, the second component is benzene. Now click on the fluid package and click on add. You can use the ideal fluid package, ideal gas equation, NRTL or Finn-Robinson. So I'm using the Finn-Robinson equation of state. So the Finn-Robinson equation of state, So I'm using this is the Finn-Robinson equation of state. Click on this one and click on the simulation. So here, this is the material stream, this is the energy stream. So this is click on material stream, drag and drop the material stream. So now define the stream. So this is the benzene air mixture or air benzene mixture. And this mixture, this benzene air is at 25 degrees centigrade. This is at 25 degrees centigrade and 1 atmospheric pressure. 1 atmospheric pressure. And the mass flow rate of the feed is suppose it is 1000 kilogram per hour. Now it shows unknown composition. So the feed mixture consists of 98% benzene and 2% air. So 2% air, 98% air. It is 98% air and 2% benzene. Very little benzene is present in this air and we want to separate benzene from air. So 98% air and 2% benzene. Click on OK. Now it is OK. The feed stream is fully specified. Okay. Now this feed stream will enter to a compressor to compress and increase its temperature. So we will click on compressor. This is a compressor. After compression, we will remove some heat from the compressed mixture to decrease its temperature. So we will add a cooler, and after cooler we will separate benzene from air using separator. So drag and drop separator, and the top of separator, from the top of separator air will be coming out from top of separator and benzene will come out from bottom of separator, and the air then will pass through well. So we will control well, drag and drop control well for the air to reduce its pressure. Okay. Now this is feed stream, it is fully specified. Double click on compressor, you can rename it. This is K100, you can change its name. The inlet to the compressor is the feed stream, and this is the compressor outlet. Compressor outlet require energy stream, so compressor energy of compressor, Okay, this compressor will increase the pressure of this feed. So this is outlet of the compressor. Click on this one, and the pressure is, suppose it is the pressure is at the compress the feed is compressed to 100 atmospheric pressure. 100 atmospheric pressure. Okay, close this one. Okay, this is compressor energy. Okay, double click on the cooler, and the inlet, this is the compressor outlet, is entering to cooler, and this is cooler outlet. Cooler outlet require energy stream, so energy of cooler energy. So it shows unknown delta P, there is no pressure drop in the condenser. We will put 0, it shows unknown duty, so we will specify the outlet temperature of the temperature of the outlet stream which are coming out from the condenser. So okay, it will condense, this condenser will condense the compressed stream to this temperature 25 degrees centigrade. So the outlet temperature will be 25 degrees centigrade. Okay, now it is specified. Now this is the compressor, the cooler energy. This is the compressor energy, and this is feed. Okay, now double click on the separator. The inlet to the separator is the compressor outlet, the cooler outlet, and this is air. Mostly this is air benzene mixture. So this is mostly air, so I will put air in the top, and this is benzene, mostly benzene, and some small quantity of air is also present in this stream. Some small amount of benzene will also present in this stream. So okay. Now this air will pass through a well, so I will connect the well. Double click on well. The inlet to the well is air. The dry air is entering to the well, and the well outlet. So it shows the unknown delta P. What is the pressure drop of this well? So the outlet pressure. This air when pass through well, the well will reduce its pressure to 1 atmospheric pressure. So 1 atmospheric pressure, 1 atm, 1 atmospheric pressure. Okay, okay. Now double click on this dry air, and click on composition. So it is 99% air and 99.49%, and very small amount of benzene is present. And here click on this stream, you will see 90% benzene is present. So 90% benzene and 10% is air. But here you can see this stream consists 98% water and 2% benzene. 2% benzene and 98% air. 98% air and 2% benzene. And here the benzene is very large. The benzene amount is quite large. You can see it is 10%. It is okay. It is 10% air. It is 10% air and 90% benzene. So how we can increase the benzene mole fraction in this bottom stream? So we can use various method, but I'm changing the uh, the compressor outlet stream. So this click on this one, go to the flow sheet, and here this is the inlets to the compressor, and this is outlet of the compressor. The outlet of the compressor is at 10 atmospheric pressure, is at 100 atmospheric pressure. So I'm changing it to 10. Suppose I'm changing it to 10 atmospheric pressure, and I will see that what will be the effect of the outlet pressure of compressor on the bottom of separator. So click on this one and check the bottom. Go to composition, and here it is 98% benzene and air is decreased. So okay, now I'm changing it to further. Click on compressor and change it to suppose 7 atmospheric pressure. 7 atmospheric pressure. Close this one and check the composition of benzene and air in the bottom of separator. Click on composition, and air it is 99%, 99.23% benzene and very small amount of air. So we conclude that when we decrease the pressure of this stream, the benzene concentration in this stream will increased. And here you can see the stream. Click on this one, and here you can see the composition. It is 98% air and 2% is benzene. Okay, so this was all about that how can we separate benzene from air. Thank you very much for your attention. If you are new to the channel, please like and subscribe.